Hello student, I hope you are doing good. In today's session, I'm gonna cover one such paper of JEE Main session 2. As you can see, I'm gonna cover the 2nd April paper, that too of morning shift. So I'll be covering all the questions of physics. So this is a question that came in your examination. It says the battery of mobile phone is rated at 4.2 volt and 5800 milliampere hour. How much energy is stored in it when fully charged? So we already have given the potential, and this is also given to you as this is charge. We already know that Q is equal to IT, and this charge is nothing but 5800 milli is 1000 ampere 100. What is ampere 100? It again you have to multiply it with 3600 in order to get ampere second. So this would be in coulomb. Okay, so this much of charge is given to you. Now the potential is also given to you as 4.2 volt. So the energy stored can be written as, that is, it could be written as the potential multiplied by charge. Potential is 4.2 and charge is 5800. Remember, you have to convert it into coulomb. Okay, 3600. So solve it. And the answer is already given in kilo joules. So the third option will come into you, which is 37.7 kilo joules. So this is the third option that you will come after solving this. Okay. Next, we'll be moving to the next question. As you can see, river is flowing from west to east direction with a speed of 9 km per hour. So river speed is already given to you. If the boat is capable of moving at a maximum speed of 27 km per hour in still water, so the cross the river in half a minute while moving with a maximum speed at an angle of 150 degree to the direction of flow, then the width of the river is. So the question says you have been given the speed of river VR, which is given to you as 9 km per hour. A boat is moving at an angle of 150 degree with the flow of river. Okay, so this whole angle would be 120. This is 90, so this would be 60. Don't you think? So with the direction of flow, it makes an angle of 150 degree. So this would be velocity of boat with respect to river. Okay, which is nothing but 27. Now, it takes half a minute to cross the river. Okay, so let the distance of the width of the river be d. So the component of this velocity along the direction perpendicular to the flow of the river, which is VBR cos 60. This is the only velocity component which is along the perpendicular direction of the flow, which make the boat to move in the straightward direction. So the velocity with which it is moving in a straight direction, it is this much, and the distance it has to cover is this. Okay, so distance would be equal to speed into time. Speed with which it is moving is VBR cos 60 multiplied by time. The time is half. Let it be t. So what is VBR, which is 27 converted into meter per second? So 9 by 18 multiply karo. So then next cos 60 is half, जो कि is half आ जाएगा, and time is given to as half minutes. Okay, half minute, that means कि 60 second. Okay, again इसको solve कर दे, width of the river आ जाएगा आपका लगभग 112.5 मीटर के लगभग आ जाएगा. ठीक है? This question is quite easy. Moment of inertia of a rod of mass capital M and L about an axis passing through its center and normal to its length is alpha. So you haven't given a moment of inertia of a rod passing through its axis perpendicular to it. Suppose L is the length and capital M is the mass. So this moment of inertia alpha is given to as ml square by 12, since it passed through its center of mass and perpendicular to it, to the length. So it is equivalent to ml square by 12. Now the rod is cut into two equal parts. and these parts are joined symmetrically to form a cross shape. Okay, so cut them and make a cross shape. So each would have a length of L by 2 and the mass of each would be m by 2. Okay, now the moment of inertia of a cross about axis passing through the center and normal to the plane. So what would be the moment of inertia of this? Okay, so the moment of inertia again would be for a single, this rod would be ml square by 12. So mass is m by 2, length is L by 2 whole square by 12. Remind you, you have two such blocks of rod. So that means you have to multiply it with 2. Okay. So because for this block also, for this rod also, half rod also, the moment of inertia would be same. So the next, this moment of inertia comes out to be this much. Now, initial, the moment of inertia was ml square by 12. The final, it is this much, the cross section. So this is equivalent to ml square by, this would be 4, and this 4 to the 8, and 2 will going to cancel out by 4 into 12. So it is 1/4 of the initial value. Okay, so the answer comes out to be the first one, which is alpha by 4. Next, consider a Bohr atomic model for hydrogen atom. The energy of hydrogen in the ground state is same as the energy of helium ion in its first excited state. First of all, we have to just check it. We already know the energy at any particular nth stage is given as minus 13.6 electron volt z square by n square, where z is the atomic number and n is the nth orbit. Okay, now at its ground state, the hydrogen-like atom has energy. Hydrogen atom has energy at ground state is, it is minus 13.6 electron volts, because for hydrogen atom Z is atomic number is 1 and N for ground state N is 1. Okay, for helium in its first excited state, that means if it is 1 and this is second, so this is your first excited state for helium, for which N would be equal to 2. So in first excited state, the energy is, the atomic number of helium is 2, so it would be equal to 2 to the 4 divided by, and n is also 2, 2 to the 4. So again, it is same, electron volt. So that means your first statement is correct. The energy of the hydrogen atom in the ground state is same as the energy of helium ion in its first excited state. Next, energy of hydrogen atom in the ground state is same as that of the lithium plus plus ion in its second excited state. For a second excited state, n must be equal to 3. So for lithium, Li plus plus minus 13.6, and Z for helium, Z is 3, so it would be equal to 9, and N is 3, so again it would be equal to 9. So again it comes out to minus 13.6 electron volts. It is same. So that means your second statement is also correct. Okay. So either AD, no, or the energy of the helium, the energy of the hydrogen in the ground state is same as that of the helium plus ion in the ground state. This is incorrect, because for helium it should be the second excited state which is having same energy as that of hydrogen atom. The helium of ion is in the first excited state is same as that of the lithium plus in its ground state. No, this is also not correct. So the only option that we are getting is A and B. So both two options are correct. Next, equation of a gas, real gas, is already given to you, where PVT and R are pressure, volume, temperature, and gas constant. The dimension of A by B square is equivalent to. So first of all, these two quantity would have same dimension. So that means A by V square would have same dimension as that of pressure. So A must have pressure into volume whole square dimension. Similarly, B would have dimension of volume. Okay, so you have to calculate A by B square dimension. PV square. V square is nothing but V square. So it is equivalent to the dimension of pressure. So which quantity would have same dimension as that of pressure? Strain won't have any dimension because it is dimensionless. Compressibility would be one reverse of bulk modulus, and bulk modulus is directly proportional to pressure. So this can't be true. Planck's constant, again, it won't have any same dimension as that of pressure. So the energy density is the last option, which is energy per unit volume. Calculate it, you will get this answer as the fourth one. Okay. So the pressure and energy density would have same dimension. Next, a relation between the magnetic susceptibility and the magnetic permeability is given as where mu naught is permeability of free space and mu r is the relative permittivity. We already know that 1 plus susceptibility is equal to relative permeability, that we already know, and magnetic permeability of a medium is given as mu naught into mu r. Mu naught is permeability of free space and mu r is relative permeability. Okay. So susceptibility comes out to be mu r minus 1. Susceptibility comes out to be, what is mu r? Mu r is mu by mu naught minus 1. So this is the answer that we are getting. So that means second option would be the correct option. Okay. Moving on to the next question. In an adiabatic process, which of the following statement is true? Molar heat capacity is 0. Yes, the first option is also is the only option which is correct. Molar heat, since you don't apply any you don't give any heat to it, so this must be equal to N C delta T. Molar heat capacity should be 0. Okay, so the first option would be the correct option. Next, match the following: coefficient of viscosity, intensity of wave, and pressure gradient and compressibility. The coefficient of viscosity is given by force is eta A dV by dl. Okay. So from this you can easily calculate the dimension of eta, and intensity is given by power per unit area, watt per meter square. Again you can calculate it, its dimension. Pressure gradient, pressure per unit length, that you can easily calculate. Compressibility would have the dimension of, it is directly proportional to 1 upon pressure. Okay, because bulk modulus is directly proportional to pressure, so compressibility is reverse of pressure. Okay, solve it again, then you will get the first option as the correct option. That means A would have dimension of m l minus 1 t minus 1 and so on. Okay, using the formula you can easily calculate the dimensions. Next, a light wave is propagated with the plane electromagnetic wave x plus y plus z is equal to constant. Remember, it is the equation of a sphere, don't you think? In a three-dimensional coordinate, this is an equation of a sphere. So that means if it is x-axis, this is y and this is z. So you will have a space in which x plus y plus z is equal to r is a constant. So this is an equation of a spherical body. Okay. So this is a wavefront. In this wavefront is already given to you. The angle made by the direction of the wave propagation with the x-axis is. So one such vector which the light rays will go perpendicular to this wavefront, don't you think? So that means if I'll gonna this is x, this is y, and this is z. So this is the vector which will go perpendicular to this wavefront. Okay, the light direction propagation is always perpendicular to the wavefront. Again, it would be symmetrical about x-axis, y-axis, and z-axis. Don't you think? It has symmetry about x. This angle would be through along y, and this angle would be along z. It would have symmetry along x, y, and z axis. So that means the angle subtended by them would be equal. That means the angle subtended along the x-axis by that vector, this light must be equal to beta, which is angle subtended along y-axis. This must be equal to gamma, angle subtended along z-axis. And from cosine law, cos square alpha plus cos square beta plus cos square gamma is equal to always equal to 1. Now we're gonna since all these three are equal, so this would be thrice of cos square alpha. Alpha is the angle that this light wave made along y-axis. So this is equal to this. Now cos square alpha comes out to be 1/3. So alpha comes out to be cos inverse 1/3. Okay. So the second option is the correct option. Cos square, this is whole square, so this would be under root 2. Okay. This is whole square, so this would be under root 2. So the second option that we are getting is the correct option that we are getting. Okay. Next. Slanted object AB is placed on the one side of a convex lens as shown in the diagram. The image is formed on the opposite side. The angle made by the image with the principal axis. What you can do is, so this image would have two parts. This is part A, this is part B. So part A is at a distance of 30 centimeter using the lens formula, and you can easily calculate where the image will gonna be formed. So this is your focus is at 20 centimeter. This is F1, this is F2, this is C2. Twice the focal length, 40 centimeter, 20 centimeter. And this is your C1, which is at a distance of 40 centimeter. Okay, so this is between C1 and F1. The image would be formed beyond C2. Beyond C2, somewhere it is beyond C2. Using the formula 1 upon F is equal to 1 upon V minus 1 upon U, where F is 25 and U is minus 30. You can calculate it. You can easily get this distance V as 60. Okay. V comes out to be 60. So the A would have an image A dash. This point would have image at a distance of 60 centimeter. Again, now for point B, it is at a distance of this distance is 1, so that means 29. When it is 29, again you have to calculate the V. When it is 29, V comes out to be 64.4. So again the V will come out to be 64.4 centimeters. Solve it using minus 29, you will get the same answer. Okay. Now, if an object is placed just like an ordinary object placed at this particular point, if I'm gonna consider this as an object, so it would have the image which is having magnification is equal to plus V by U. Okay, V is already calculated as 64.4. Okay, and U is minus 29. From this, magnification comes out to be 2.2 or minus 2.2, from which the length of the image comes out to be, it would come out to be twice of 2.2 times of 2 centimeters. So which is nothing but 4.4 centimeters. So somewhat like you will get the image just like this. Okay, this length will becomes 4.4. Okay, now you need to calculate this angle. Obviously, this angle has to be negative. So one such option which is positive is incorrect. So it is close to 4.4, and this is also close to 64.4, which is nothing but 4.4. So that means these two distance would almost be equal, and this is 90, so this would be close to 45 degree, minus 45 degree. So first option is the correct option that you must get. Okay. Next, let B1 be the magnitude of magnetic field at the center of the circular coil of radius r. At this particular point V1, the magnetic field is V naught I by 2R. Okay, it is having current and radius R, so magnetic field at the center would be mu naught I by 2R. Let B2 be the magnitude of magnetic field at an axial point. So if I'll gonna see this from this end at an axial point, which is at a distance of x is equal to this x by ratio, it is equal to 3R by 4. The magnetic field comes out to be B2. Okay, magnetic field on an axial point, that we already know, it is calculated as B2 is mu naught I R square divided by 2 x square plus R square power 3 by 2. So this is how you calculate the magnetic field on an axial point. Okay, this axial point it is at a distance of 3R by 4. So B2 comes out to be squaring both the side 9 by 16 R square plus R square. Okay, and 3 by 2. You can take R square can come out. So and this would be equal to R square can come out. So squaring would be equal to R cube, and then again R square and R cube, from which you will get in the denominator you will get R. Okay, from B, and you have to calculate B2 by B1 at the final point. So B2 by B1, in which mu naught I by 2R will gonna cancel out. Okay, mu naught I by 2R will gonna cancel out. So eventually you will get this expression as 16 plus 9, which is 25 by 16 3 by 2. This is the final expression that we are getting after solving it. So this is nothing but 5 whole square by 4 whole square. 2 will gonna cancel out. 5 by 4, so it will go up. So from this is whole cube, 4 into 4 into 4, and this would be 5 whole cube, 5 into 5 into 5. So this is 64 by 125. The final answer that we are getting is the third option. Okay. Next, x1 and x2 are the two simple harmonic wave which is given to you. Okay, where x is the displacement and t is in times in second, and again it is in centimeter. The maximum acceleration of the particle is, the resultant of these two would have maximum acceleration. So again, how you can calculate the resultant displacement x, which is x1 plus x2, using a phasor diagram. We can easily calculate it as the amplitude of first is √7, amplitude of second is 2 √2, and it has a phase angle of the phase difference between them is pi by 3. That means the angle between them is pi by 3, and this distance is 2 √7. Okay, this is how you can easily calculate the resultant. So the resultant comes out to be under root this whole square, which is 7, plus under root of this square, which is 2 to the 4, 4 7 is 28, plus 2 R1 R2 A1 A2. So this comes out to be 2 A1 into A2, which comes out to be 7 to the 14 cos, the angle between them is pi by 3, which is cos 60 degree. It is nothing but half. So 2 will gonna cancel out. Eventually you'll get 28 plus 14 plus 7. Okay. So this would be 9, 49. So the resultant comes out to be 7. Okay. So the resultant amplitude would be 7. Now what would be the acceleration? Maximum acceleration is given by a omega square minus of a omega square. Okay, and amplitude it came out to be 7. The resultant amplitude came out to be 7, and omega square. Omega is in the expression is 5. 5 has a 25. Okay. From this we get it as 175. Again, remember one thing, this amplitude is in centimeter. So this would be into 10 raised power minus 2. So 10 raised power minus 2. So it comes out to be, so x comes out to be 175. The fourth option is the correct option that we are getting. Okay. Next, a small bulb of mass 100 milligram and charge 10 microcoulomb is connected to an insulating string of length 1 meter. It is brought near to an infinitely long non-conducting sheet of charge density sigma. If the string subtend an angle of 45 degree with the sheet at the equilibrium, the charge density of the sheet will be. So what should be the charge density? So at an equilibrium position, weight will act in the downward direction. Electrostatic force QE will, because of the sheet, will be acting in this particular direction. The tension in the string, let this angle be theta, this angle would also be theta. So T cos theta will balance weight, and the tension in the string is T. So the T sin theta component of the string will gonna balance QE. Okay. Again, take a ratio. TT will gonna cancel out. Tan theta comes out to be QE by mg. Okay. Okay. This cos component would be balancing the weight. Yes. And the sin component would be balancing them. Okay. So this is correct. Tan theta is already given to you as 45, 10, 45 degree. It is already given to you 45 degrees. So 10, 45 is 1. So mg is equal to QE. Okay. From this, this is an infinite sheet which will produce an electric field which is given by sigma by 2 epsilon naught. Okay. Which is sigma is the charge density of the sheet that you need to calculate. So sigma, from this, sigma comes out to be 2 mg epsilon naught by Q. Mass is already given to you 100 gram, converted into kg. G is also given to you, absolute is already given to you, and charge is also given to you. From this you can easily calculate charge density in nano coulomb per meter square, and it comes out to be 1.77. Okay. Next, a monochromatic light is incident on a metallic plate having work function phi. An electron emitted normally to the plate from the point A with the maximum kinetic energy enters a constant magnetic field perpendicular to the initial velocity of the electron. The electron passes through the curve and hit the point plate at a point B. The distance between point A and B is the magnitude of charge of electron is E and mass is m, and h is the Planck's constant, and c is the speed velocity of light. Take the magnetic field exists throughout the path of the electron. Suppose this is sheet and electron are ejected at point A. Okay, and perpendicular magnetic field exists in the region. Okay, so this electron after coming out of this plate with a maximum kinetic energy kmax, it would have certain velocity, and because of this magnetic force which arises because of this magnetic field, it will gonna move on a circular path and it will hit the point B. Okay, remember the force always acts towards the center, which is this is the center, which is this magnetic force comes out to be QVB. Okay, this will provide the necessary centripetal force, and the radius of this trajectory that we already know as mv by qb, where if a charge body moves in a magnetic field perpendicular to the magnetic field, so this would be the radius of that particular moving charge body, mv by qb. Okay, so mass is mass of electron and velocity with which it is moving. Uh, this could also be written in the form of momentum. So m into v is momentum of the electron divided by qb. Okay. The maximum kinetic energy of the ejected electron that we already know is given by relation hc by lambda is the energy supplied to the plate. This will be utilized as in the work function plus maximum kinetic energy of electron. Okay, so the Kmax comes out to be hc by lambda minus phi. So the distance between A and B is twice of radius. This comes out to be twice of radius. Twice of r is the distance between A and B. Okay, so this would be 2 momentum divided by qb, and momentum is already given to as 2mk by qb. Momentum and kinetic energy relation is root 2mk. Okay, from this 2 will gonna go inside. We have 8 m. Kinetic energy is given to as hc by lambda minus phi by E into B. The charge of electron is EB. Which option that we are getting? The second option is the correct option that we are getting. Okay, by EB. Next, a point charge Q is placed at the origin. You have a point charge Q placed at the origin. A second point charge of plus 9q is placed at a distance of d comma 0 0 n, the Cartesian coordinate, the point in between them where the electric field vanishes. At what point the electric field would be 0? Suppose that this is the point at which electric field because of these two would be 0. So electric field because of the small q charge, let it be E1, and the electric field because of this charge 9q, it would be E2. So E1 must be equal to E2 in magnitude, so that the magnetic field because of these two will gonna cancel out. Let this be at a distance of x. So at x distance, the magnetic field because of small q charge is kq by r square. R distance is x, so this would be equal to x square. Because of this 9q charge, the electric field E2 is kq 9q by r. The distance between them is d, so this distance is d minus x whole square. Okay, kq will gonna cancel out. This comes out to be here d minus x by x whole square is equal to 9, so is equal to 3. D minus x is 3x, d comes out to be 4x, and x comes out to be d by 4. So that means at a distance of d by 4, the electric field would be 0. The coordinate of this point, this point would be d by 4 comma 0 comma 0. So the first option is the correct option that you must get. Next, a laminar body is already given to you, having length at 10 centimeters pivoted at point 0. The force acts at lamina shown in figure is already given to you. If the lamina remains stationary, then the magnitude of F force is. If lamina remains stationary with respect to this particular point O, so that means torque acting on this laminar body must be equal to 0 at a point O. With respect to O, the torque must be 0. Okay. Now we're going to calculate the torque. The net torque is already given to you as 0 because it is not moving, so that means not rotating, so that means net torque because of all these force must be 0. So at this particular point, torque because of this 10 Newton would be 0 because it is along this particular point. Because of this force, you will get R cross F. Let this length is A. So R cross F, so clockwise, this would be anti-clockwise torque, which we're gonna take it as positive. So it would be equal to Fa, and because of 10 it is 0, and because of this 10 it would be R cross F, which is, and because of this it would be anti-clockwise plus 10a. The perpendicular distance of this would be a, and because of this the torque would be into clockwise direction, and again would be clockwise direction is taken to be negative minus 10a. These two will gonna cancel out, so the net torque because of these two would be 0. Because of this 10, then the torque would be 0 because there is no perpendicular distance, and because of this 10 coulomb the perpendicular distance is a, and it is clockwise torque which is minus 10a. The net torque is 0. These two will gonna cancel out, so Fa is equal to 10a. A will gonna cancel out. The force comes out to be 10 Newton. Okay, so the second option is the correct option that you must get. Next, a Zener diode with 5 volt Zener voltage is used to regulate an unregulated DC voltage of input 25 volt. Okay, you have to regulate a DC voltage of 25 volt using a Zener diode of 5 volt. For 400 ohm resistor connected in series, the Zener is found to be 4 times load current. So Zener has 4 times the load current. The load current IL and the load resistance RL is. So if you're gonna connect a 400 ohm resistor and a Zener diode, which always acts in the reverse biasing condition, it has a potential difference of 5 volt, and a load is connected across it. Okay, from this the load current is 4 times. This load current is 4 times as that of this Zener current. This Zener current is 4 times as that of load current. Okay, 4 times the load current. Let the current along the load RL be X, so this would be 4x, don't you think? I have taken it as in the form of X. Let this be X, so this would be 4x. Okay, the potential difference across Zener diode is 5 volt, so the potential difference across the resistor would 400 ohm would be 20 volt, because sum of these two would be 25. The current supplied would be I equal to V by R. I equal to V, what is V? 20, and R is 400. So it comes to 1 by 20. So you are supplying 1 by 20 ampere current. Okay, at this junction it will gonna divide into two sections. These two would combine to and it will come out to be 150. So this is 4x plus 5, which is 4x plus x, which is 5x. This must be equal to 1 by 20. So x comes out to be 1 by 100 ampere. Okay, current along the load is 1 by 100 ampere. So the current along load is 4x is 4 into 1 by 100, which comes out to be 1 by 25 ampere. Okay, so the load current comes out to be 1 by 100 ampere, which is nothing but 0.01 ampere. Okay, and this could also be written as 10 milliampere. Okay, so that means the load current comes out to be 10 milliampere. So load, the resistance across it would have the same resistance as that of this diode. So this load resistance is RL is the current multiplied by voltage. Voltage by current. Voltage is 5 and the current is 1 by 100, so which is nothing but 500. So it eventually comes out to be 500. Okay, so the third option is the correct option that we are getting, RL 500 and the load current as 10 milliampere. Next, consider two infinitely large plate parallel conducting plate as shown in below. The two plates are uniformly charged with a surface charge density sigma and minus 2 sigma. The force experienced by a plus q charge placed at the midpoint between the two plates is because of this plate which is having charge density sigma and it is having minus charge minus 2 sigma charge density. At this particular point, the electric field because of this would be sigma by epsilon naught, 2 epsilon naught, and it is away from it because of this minus 2 coulomb, because of this negative sheet which is having charge density minus sigma, the electric field would be again it would be in the same direction. Because of this sheet, negative sheet, the electric field would be towards the sheet, and because of this electric field is again sigma by epsilon naught. What is sigma over here? 2 sigma by 2 epsilon naught. Sigma by 2 epsilon naught. Okay, this is the expression that we are getting. So this comes out to be 2 plus 1, which is 3 sigma by 2 epsilon naught. So this is the electric field at this particular point. So the force would be equal to Q times of E electric field. So 3 sigma Q by 2 epsilon naught. So this is the final expression that we are getting, which is the third option that we are getting is the correct option. Okay. Next, chord of negligible mass is around the rim of a wheel supported by a spoke with negligible mass. The mass of the wheel is 10 kg and the radius is 10 centimeter. It can freely rotate without any friction. Initially, the wheel is at rest. If the steady force of 20 Newton is applied on the cord, the angular velocity of the wheel after the cord is when the cord is unwound by 1 meter could be. So that means you are continuously applying 20 Newton force, because of which torque will gonna make it to rotate, and you need to find out the angular velocity after 1 meter of wire is taken out. Okay, so if 1 meter of wire comes out, the work done by this force would be equal to force into displacement. Force is 20, displacement is 1, so that means 20 Newton of work is 20 joule of work is being done. Okay, this work would be stored, will gonna increase the rotational kinetic energy, so it would be equal to change in kinetic energy, rotational kinetic energy of this. So the initially it was at rest, so final initial was 0, the final is half I omega square, because initial is kinetic energy was 0 because omega was 0. Okay, since it is a wheel, so wheel would have a mass, the moment of inertia as mr square omega square, and this comes out to be 20. So this is 2 to the 440. Mass is already given to you as 10 kg, and radius is already given to you as 10 centimeter. Radius of this wheel is 10 centimeter. So 10 by 100 whole square omega square. Okay. Solve it, you will get omega as 20 radian per second. Okay. A spherical surface separates two medium of refractive index 1 and 1.5 as shown in figure. Distance of the image of the object O is the center of is that you need to find out, where C is the center of curvature of the sphere and R is the radius of curvature. Okay. So N1 is 1 and N2 is 1.5. An object is placed at a distance of 2.4, so U is minus 0.2 meter. So the image would be formed somewhere in the next medium, and that's this V that you need to calculate. We already know the refraction through curved a spherical refracting surface formula as mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R, where R is the radius of curvature of that refracting surface. The second medium is 1.5. We need to calculate. Mu1 was the first medium N1, yeah, mu1 having refractive index 1, and this U is minus 0.2, will minus 0.2, minus minus plus 0.2 is nothing but 2 by 10. Okay, mu2 minus mu1 is 1.5 minus 1, which is 0.5. And radius of curvature is plus, because since it is along the direction of light, r, which is 0.4. Okay, so this could be written as 3 by 2v, 3 by 2 by v plus 5 is equal to 5 by 4. You can easily solve it. Okay, so this 3 by 2v is nothing but 5 by 4 minus 5. So this comes out to be 5 for the 20 minus 5, so minus 15 by 4, and this is 3 2v and 2 to the 4, so 3 to the 6, 6 by minus 16 by 5. Okay, so which is 0.4. So this is, and it comes out to be in the form of negative, so v comes out to be minus 0.4 centimeter. Okay, so that means the image would be formed from over here, and image would be formed at negative sign shows that image would be formed in the same side, and it is at a distance of 0.4. 0.4 to the left to the spherical surface. So the first option is the correct option that we are getting. Okay. Next, person travel on a straight line moves with a uniform velocity v1 for the distance x and with uniform velocity v2 for the next 3x by 2 distance. The average velocity in the motion is 50 by 7. So, and v1 is also given to you, so we need to find out v2. The average, v average, that we already know is total distance by total time. Total distance is x plus 3 by 2x. Total time is for x journey, the speed is v1. So time is distance upon speed. So x by v1. For next journey, velocity is v2. So time would be distance upon speed. Distance is 3 by v2. Okay, this average velocity is already given to you as 50 by 7. Also v1 is also given to you, so you need to find out v2. X will gonna cancel out, x comes out to be, so x will gonna cancel out, it is 1 by 1 plus 3 by 2, and 1 upon v comes out to be 5, it is, which is already given to you from this 3 by 2 v2, and it is given to you as 50 by 7. Solve this, you'll get the v2 as 10 meter per second. Okay. Next, gamma A is a specific heat ratio of monoatomic gas having 3 translational degree of freedom. Okay, so gamma, it is a monoatomic gas which has 3 translational degree of freedom. The degree of freedom is 3. So Cv comes out to be Fr by 2, which is 3R by 2, and Cp for it is R plus Cv, 3R by 2. So it comes out to be 5R by 2. So gamma for this monochromatic gas is 5 by 3. Okay. Gamma B is the specific heat ratio of polyatomic gas B having 3 translations. The second gas which has 3 translational degree of freedom, 3 rotational degree of freedom, and 1 vibration. 1 vibration would constitute 2 degree of freedom. Na? So in totality, the degree of freedom FB is 3 plus 3, which is 6, 7, 8. So 8. So degree of freedom comes out to be 8. CV for B comes out to be 8 R by 2. So CP for B comes out to be, remember this is for the first gas. Okay, so gamma A, and this is R plus 8R by 2, which is 10R by 2. So gamma B, which is the ratio of CPV by CV, so it is 10 by 8. So you need to find out the ratio of gamma A by gamma B, which is 1 plus 1 by 10. So gamma A 5 by 3 by gamma 5 by 3 by gamma B, which is 10 by 8. This is 1 plus 1 by n. Okay, solve it, you'll get the value of n as 3. Okay, इसको solve कर लो, आसानी से 3 आ जाएगा. 5 to the 10 and this is 8 by 6 minus 1 is 1 by n, है ना? So this is 2 by 6 is equal to 1 by n और 2 3s are, so n comes out to be 3. ठीक है? Next, a vessel with a square shape and a height of 6 meter is vertically partitioned. So that means you have been given a square shaped vessel with a vertical partition. That means it is divided into two equal parts. From front, if I'm gonna draw it from front, it is divided into two equal part. So it is having length of 6 meter at a depth of a small window of 10 centimeter square with hinged door is fitted at the bottom of 3 meter in the partition wall. So in the partition wall there is a wall. Okay, this section, these two are partitioned. So it is having length of 10 cent. That means its area is 10 centimeter by 10 centimeter. So that means 10 centimeter, 10 centimeter it would have length. Area is 10 centimeter square. Okay, we can take the length as 10 centimeter and breadth 10 centimeter. Now it's fitted at a depth of 3 meter. So that means the depth is 3 meter in the partition wall. One part of the vessel is filled completely with water. One part is filled with water and the other part is filled with liquid having density this much. Another part is filled with some other liquid having density which is already given to you. Okay. Next, what force one need to apply on the hinged door so that it does not open. So that means this liquid would also apply some force. This liquid would also apply some force. Okay, and the area of this window is already given to you as 100 centimeter square. At a depth of 3 meter in this liquid and in this liquid, let this depth be h. At this depth, the force acting on because of this liquid and because of this liquid would be it would be more the pressure, because the pressure is rho gh, density is more as compared to the water, so the pressure over here is more. The pressure multiplied by area would be the force applied by this liquid. The force applied by this liquid is pressure of the second liquid, let it be B into area. Okay, so this is FB and let this be FA. And FA comes out to be pressure at the depth multiplied by area. Okay, so this would be FB minus FA that we need to calculate, and this is A we'll gonna take it as common. FB is PB minus PA. Okay, pressure is rho, density of liquid is, this liquid is 1500. Okay, rho G H minus density of water is 1000 rho G H. Okay, remember it is at the same depth, so GH will come out AGH multiplied by 500. Area is 100 centimeter square will be converted into, so minus 4, G is 10 and depth is 3 multiplied by 500. Okay, solve it. you'll get the answer as 150. Next, if the measured angular separation between the second minima to the left of the central maxima, so we're gonna draw the diagram. Suppose this is a screen and this is a slit. This is the central maxima and the maxima to the left and the maxima minima to the right. Okay, width, let this width be A. Now it says this is a central maxima. Okay, it says the angular separation between the second minima to the left. Where is this is first minima, this is second minima. Okay, so this is second minima and the third minima. This is first, second and third. So this is your third minima. The angle between them, third minima to the right of the central maxima is 30 degree. Okay, let this angle be theta 1, let this angle be theta 2. The sum of theta 1 plus theta 2 is given to you as 30 degree. In a single slit diffraction pattern using 628 nanometer light, then width of the slit is, you need to calculate this width of the slit, single slit. We know that width, we know that the angular separation for the minima is given to you as n lambda by A. Okay, the angular separation for the first minima would be, and for first minima n would be 1, for second minima n would be 2, for third minima it would be n would be 3. Okay, so theta 2, it is at a distance of third minima. Okay, so this would be 3 lambda by A, and theta 1 towards the left, it would be the second minima, so this would be 2 lambda by A, and theta 1 plus theta 2 is already given to you as 30 degree. 30 degree is nothing but pi by 6, which is 3 plus 2, which is 5 lambda by A. Okay, so A comes out to be 5 6 is 30 lambda by pi. So 30 by pi, and angle and the width you have already given the wavelength as 628 nano, which is 10 to the power minus 9. You can easily solve it. You will get this as 6 micrometer. The answer is already given in micrometer, remember. Okay, so you'll get it in micrometer as 6. You can put the value of pi as 22 by 7. Next, a steel wire of length 2 meter and Young's modulus is stretched by a force. The Poisson's ratio and the transverse strain for the wire is already given to you. The elastic potential energy density of the wire is this much into 10 to the power 5. So we already know the elastic potential energy is given as half lambda into strain. This is longitudinal strain whole square. What do you think? And Poisson's ratio is the ratio of lateral strain to the longitudinal strain. So the longitudinal strain is lateral strain divided by sigma. Lateral strain, which is also called as transverse strain, which is already given to you as lateral strain is 0.2, and the Poisson's ratio, okay, no, Poisson's ratio is 0.2 and lateral strain is 10 to the power minus 3. Okay, from this you can easily calculate the longitudinal strain. Lambda is also given to you. The Young's modulus is already given to you. So from this you can easily calculate U, and it comes out to be 25 into 10 raised to power 5. So this you need to write it as 25. Okay, I hope all the questions that I have discussed is understood to you. With this, I'm gonna end up today's session. Thank you.